This particular video, future value estimation in the case of a single cash flow, is especially meant for the beginners. Hello all, welcome to Sri Classes. I am Srikanth. Today we will be discussing calculation of future value in case of a single cash flow, otherwise lump sum method. Let us discuss the meaning of future value. Future value is nothing but tomorrow's value of today's money, which means the future value is the amount of money a given investment will be worth after a certain period, assuming a specific rate of return, otherwise interest rate. Let us see a following example. Considering a 3 years time frame, if I have a cash flow of 1000 rupees today and I would like to invest, then how much it would be after 3 years at a given rate of interest. To find out this future value of money invested today or cash flow today, we generally estimate the future value using compounding process. And compounding process is used to estimate the future value of money invested. And it's a process where interest on a loan or deposit is calculated based on both the initial principal and accumulated interest from previous period. Otherwise, you can simply understand, in the case of compounding process, interest at the end of every period is added back to the principal. Otherwise, interest will also earn the interest in this case. Let us look at how the compounding interest calculation is done and how it is different from simple interest. So, in the case of a single cash flow, future value, let us look at the following example. In this example, we are discussing compound interest versus simple interest. Taking an example of FD, fixed deposit of 1000 rupees, where interest earned is assumed to be 10%, for example, and for a period of 3 years. Let us look at the calculation of compound interest and simple interest. In the case of compounding interest, interest is accumulated to the principal and interest will earn the interest, whereas in the case of simple interest, interest is always fixed for all the periods for which we estimate the value of money. So, let us look at the compounding process. The first year, 1000 rupees and 1000 rupees into 10% interest, which is 100 rupees, plus 1000 rupees. At the end of first year, the 1000 rupees, the value is 1100 rupees. 1100 rupees will become the principal of the second year. 1100 rupees on which 10% interest is calculated and added back to the principal amount 1100. So, at the end of the second year, the value of 1000 rupees is 1210 rupees. And this 1210 rupees will become principal for third year. 1210 rupees on which 10% interest calculated will give us 1331 rupees. So, 1000 rupees invested today, compounded for a period of 3 years at a rate of 10% will give us 1131 rupees. Whereas in the case of simple interest, for all the periods, we are just considering the basic principal, that is 1000 rupees, for the calculation of interest. Let us see this example. 1000 rupees invested today at 10% interest is 100 rupees is the interest rate. At the end of first year, the value of 1000 rupees is 1100. At the beginning of second year, the amount invested is again 1100, but we will be considering only 1000 rupees for the calculation of interest, which earns only 100 rupees interest for the second year also. At the end of second year, the amount is 1200, and 1200 in the beginning of second year. In the case of simple interest calculation scheme, 1000 into 10% is 1300. See the difference between the compounding process and simple interest scheme. In the case of compounding interest, as interest is added back to the principal, so the compounding process, because of power of compounding, is earning additionally 31 rupees more than the simple interest scheme. Taking the logic from the compounding process, let us look at the formula for calculating the future value. Future value is equal to present value into 1 plus k to the power of n, where PV is equal to present value or amount invested or received today. FV is equal to future value of the money at a future given point of time. K is equal to interest rate or discount rate. N is equal to number of years or It represents time period for which we estimate future value of the cash flow. This particular portion in the formula 1 plus k to the power of n is called as future value interest factor. As the resultant value of this particular portion is multiplied with present value to estimate future value, this particular portion of the formula 1 plus k to the power of n is called as future value interest factor. The example for the future value calculation: find the value of ₹1000 invested in a fixed deposit for a period of 3 years. Assume the rate of interest that fixed deposit earns is 4% per annum. Now, first step here is to apply the formula. The formula to be used here is future value is equal to present value into 1 plus k to the power of n. Let us look at the values from the given example. The present value of cash flows or the amount invested now is ₹1000. Rate of interest is 4% as per the given example. Number of years. Deposit period is 3 years. Let us look at the calculation. Substitute these values into the formula. F is equal to 1000 into 1 plus 0.04 to the power of 3. See, whenever the percentage of interest is given, we are required to take in the ratio form like 0.04 if 4% is given. Same thing we have done here. It is 1 plus 0.04 to the power of 3. Now, the resultant value is 1000 into 1.124864. So, this particular portion in the formula is called as future value interest factor, and it is generally represented in this pattern. The final answer is future value is equal to ₹1124.864. What does it mean? It means that if we are investing ₹1000 today for a period of 3 years, which earns an interest rate of 4%, then the future value of this ₹1000 will be 1124.864. Now, let us look at future value interest factor table. Future value interest factor table is a table which contains the future value factors for different interest rates and for respective years. So, interest rates are taken horizontally and number of years are taken vertically. Suppose the future value interest factor, if I am considering 6% interest rate or rate of return on investment, and my investment duration is 5 years, then future value interest factor for this combination we can map to 1.338. So, I can take this 1.338 and multiply with the amount invested to find out the future value. So, as per the given example earlier, 4% is the interest rate and investment period is 3 years. Then we can map the interest factor to 1.125. Remember, in this particular table, all the interest factors, future value interest factors are approximated to 3 decimals. So, 3 or 4 decimal approximation is always better. So, we have seen the earlier example, the future value interest factor what we have considered is very close to this given future value interest factor given in this table. Future value interest factor table is generally useful in the case of complex calculations. We did not use the formula always. You can take these interest factors from this table and multiply with the amount invested to find out the future value of the money. And all the values, all the future values in this table again are calculated with the similar formula that we have discussed earlier, that is 1 plus k to the power of n, where k is the interest rate, n is number of years. Hope this video is helpful in understanding future value calculation in the case of a single cash flow. Thank you very much for watching. Please like and subscribe this video.